Why is there a gate around cemeteries? Because people are dying to get in. Hey guys, welcome. This is our first problem from our net force section on our forces worksheets. So, my car has a mass of 1,577 kilograms. What is its weight in newtons? What is the force normal? If I then lift up on my bumper with a force of 1,334 newtons, what is the new force normal acting on the car? And what if I let go of the car and sit on it with 4 of my friends, 5 of us total, each of us having a mass of 90 kilograms? What would be the force normal then? So let's go ahead, and we're just working with a few variables here, so we're going to have force, mass, and acceleration. So let's make a variable list. And we're actually going to have 2 forces, F weight and F normal. And just a quick little free body diagram. We've got the force of gravity here, that's the force of weight, and then the force normal here. So if my mass is equal to 1,577 kilograms, 1,577 kilograms, and I want to know the force on it, well, then I need to use the acceleration times the mass in F equals ma. And the acceleration is going to be due to gravity. Whenever we're working with weight, we're looking at the acceleration due to gravity, which is 9.8. Perfect. So, quick calculation. That gets us a force weight equal to 15,454 newtons. And then our force normal is going to be equal and opposite because of Newton's third law, remember. So that's going to be a negative 15,454. Now notice, I've set my acceleration to positive just the way that I wrote it. So therefore my force going down must also be positive. We're still keeping our frames of reference the same. And then my force normal has to be the opposite. So if it's going up, it is negative according to this frame of reference. So then if I lift up on the bumper with 1,334 newtons, modifying my free body diagram, we're just adding in a force, and we'll call it F1. And F1 is equal to 1,344 newtons. Is that what I said? That is not what I said. 1,334. There we go. So if I want to add these forces together, my force normal is ultimately going to be equal to the force of my weight plus F1. And F1 is up, and up I've defined as negative, so it's got to be negative. So when I can do this all the time. F is equal to ma, but any F net, any resulting force is going to be equal to the addition of the forces that make it up. So F of weight is 15,454 newtons plus a negative 1,334 newtons is going to equal 14,120 newtons. So that'll be my new force normal. Excellent. And then if I let go of the car, so I've removed this force, and then I'm adding a new force going down. And that's going to be me plus 4 of my friends, so 5 of us, 5m, and we'll say mf for m friends, mass of me and my friends. So 5 times mf. And mf, we'll just add that variable in. See what I mean here? In our last unit, we had a lot of different variables, but suddenly I've already got 3 forces and 2 masses. We start to get a lot of the same variable repeated over and over again in our forces unit. And a lot of the time it is just looking at different forces and different masses. So it's going to be pretty important to, as we get into more complex problems, to keep our variable list nice and steady. But for now, we're just going to do this one a little dirtier. So MF is equal to 90 kilograms. And that's 90 times 5 to get the force of this. So 90 times 5 is going to be 450 newtons. is 450 total kilograms times a 9.8 to determine the force going downwards. So that's going to be 4,410 newtons. And then adding all of these together, so the force normal, once again, is going to be equal to force of my weight plus the force of my friends. So, F weight is 15,454 plus a positive, because it's going in the same direction, force of my friends of 4,410 newtons, equal to a new force normal of 19,864 newtons. So these are some nice, pretty simple calculations. We're just looking at one equation, F equals ma, and looking at the addition of forces. So for our next problem, let's get into something a little more complex.